to find the quotient and then write the answer in standard form. What's wrong with number 17 is you can't have an imaginary or radical in the denominator, so you have to rationalize that. So the deal is that conjugate. Remember, conjugate means just times it by the opposite sign, the same binomial with an opposite sign. Whatever you do to the bottom, you have to do to the top. Keep the balance on the fraction, so it's like you're timesing by a form of 1. All right, again, just times by the opposite sign. It just works like magic. When you FOIL this together, you should always get a rational number. So it rationalizes the denominator. So first is 25. Outer is negative 15i, and inner is positive 15i. Guarantee the inner, outer would cancel. You may not even want to write that down. Last. Positive times negative is negative, but because of the I times I is I squared. I squared is assigned the value of negative 1. So the negative 1 will change the sign of that term to positive 9. Anytime you have I squared on a term, it will change the sign of that term. So we really have a 25 plus 9, which is 34. So the denominator FOILed, rational number, 34. All right, then for the numerator, FOILing that out does not mean that you're going to get a rational number at all. So unrelated might be a mess. First is 40. Outer is negative 24i. Inner is negative 30i. And last times last, because it's negative times a negative, it is positive 18i squared. But then the I squared will change it to negative. So ultimately, negative 6i times negative 3i is negative 18. So you have a 40 and a minus 18, which is 22. Negative 24i and negative 30i is negative 54i over the 34 in the denominator. Then it says in standard form, which means you want to split it apart and write the real part separate from the imaginary part. So the 22 over 34 is one fraction. And the 54 over 34 is the other fraction that has the I on it. Those will reduce. That's 11 over 17 and maybe 27 over 17. Like that would be standard form. Standard form means the real part separated from the imaginary part. Both of these are divided by 34. All right, number 18. Number 18 asks us to fill in this for the x value, so subbing in for x, it will be negative 7 plus 9i squared minus 9 times negative 7 plus 9i plus 4. And then use what we know about i's and distributing and all that to just work this out. If you're not real positive about that squaring pattern, I always say to FOIL that out. Ideally though, when you square a binomial, you'll say square the first, times together and double the middles and square the last. That is the squaring pattern, squaring a binomial. But like I said, if you make any mistakes on that, it's not worth it. If you just want to go FOIL it out, that's fine. So first is 49. Squaring is timesing by itself. 49 minus 63i, another minus 63i, and last is positive 81i squared. So exactly the squaring pattern. Square the first, times together, double because get that repeated, and then the square the last. That will simplify to I squared makes that minus 81. So you have 49 minus 81, and what is that? Negative 32 maybe? Would somebody check me on that? 49 minus 81? Okay, and negative 63i and negative 63i is negative 126i. So that all came from that. That's what we were doing. We were squaring that binomial. I still need to distribute the negative 9, which is plus 63. Negative 9 times 9i is negative 81i, and then plus 4. So we're not solving anything on this, and we're just kind of combining like terms, reducing it. So we have a negative 32, a positive 63, and a positive 4. Combine all those like terms. It looks looks like you would have positive 35, negative 126i, and negative 81i is, I think, negative 207i. And in standard form, you always put the imaginaries behind the real part. Okay, any questions on that? Okay, number 19. 19, the directions say to solve. Now, there's one answer that you can get to by just cubing each side or cube rooting each side. If you take the 64 across the line and take the cube root of each side, you do catch one of your answers, the real answer part of it. But because it is third degree equation, we are supposed to account for all three solutions. And the only way you can find all your solutions is if you're able to break down higher powers by factoring or something. So there is a pattern for factoring perfect cubes. Looks like this. Both of these are perfect cubes. You take the cube root of each. It is a plus, so it will be plus here. Then you square this, multiply together 4x, change the sign to minus 4x, and then the square of 4 is 16. If you could, you would factor that down and try to get it completely in linear factors. But it will not factor, so once you've factored all you can, you set each parenthesis or each factor equal to 0. That gives you the one solution that we kind of suspected, the negative 4, but then it gives you these two other solutions which you have to find with the quadratic formula. So they're imaginary, they come out to be, but you still have to account for them. So the quadratic formula, you do A is 1, B is negative 4, C is 16. Plug that in. I won't work that all the way out. I'll let you practice on that and verify that. It does come out to be 2 plus and minus 2i radical 3. So you have 3 solutions. This is one, and then plus and minus would account for 2 more solutions, so the 3 solutions that we need to account for. Okay, number 20. Solve for t. This is kind of an abstract problem because it has a lot of letters in it, you know, because normally when we're solving a quadratic, we have some numbers, like the problem we just did on 19, we had nice coefficients in front of the square term, but I want to direct you back to this number 19. Notice that I knew this was a quadratic. I was supposed to be solving for x. If the variable you're solving for is squared, that means it's a quadratic. So that's what's going to happen to me on number 20. I'm solving for t, and t is squared. So it is a quadratic. The only way to solve a quadratic is to either be able to factor it, complete the square root property, or use the quadratic formula. And especially if it's difficult, we use the quadratic formula. So that's what we would be doing. So to use the quadratic formula, what we did is in front of the square term, we picked that coefficient up. That was our a value. In front of the x to the first term, you pick up that number, that's your b term, negative 4. And then the c is the constant. Now listen, normally when you think of a constant, you think of a number. It's going to be different on this number 20. So, but notice, really what we're doing is the constant is the term that doesn't have x in it. It doesn't have the variable you're solving for. So we're calling that a constant, and that's c. And I think it was clear in that example. But let's see if we can pick it up in number 20. All right, because it says we're solving for t, I pick up that t is squared, which makes it a quadratic. So I want to get it all equal to 0, standard form. So this Rm does not have a t in it, so that's actually going to be a constant. All right, Rm, and I change sides, so it's minus Rm equals 0. So to use the quadratic formula, we would say a is what's in front of your squared term. So t squared's coefficient is 1. B is what's in front of t to the first. Here's t to the first, so what's in front of it is negative m. And then c is the constant, or the part that doesn't have the variable you're solving for on it. It doesn't have a t on it. So that's a constant. I know it's weird because those are letters, but that would be, in this case, considered the constant of that quadratic. And then we're going to plug it into the quadratic formula. So the quadratic formula says the negative of b, which makes that a positive m. So it's negative b, the negative and negative m or positive m, plus or minus b squared. So the b term is negative m. When you square that, the negative squared is positive. So it'll be m squared. Then minus 4 times a times c. Okay, a is 1, and c is that negative rm, that weird constant. All over 2 times a is 1. Luckily we had something that was just normal there. And then clean that up. That will be m squared minus 4 times 1 times the negative rm. If you have double negatives there, if you have an even amount of negatives when you multiply, that makes that plus. 4 times 1 is just 4. So it's plus 4rm over 2. And that's the answer to that. It does not simplify it down. Some good questions that you might think through here is, can you square root this m squared and bring it out? And you cannot because of the plus sign. Remember, you can't take individual square roots when there's a plus sign in it. We can't even the 4, even though 4 is times rm, as long as you have a loose plus sign in your string of terms, you cannot individually take square roots from each one. All right, so any questions on that? Okay, let's see if we can get a couple more.